Hey folks, welcome to this episode on a whole bunch of stuff. To be honest, what we're going to be looking at is we're going to be looking at a lot of calculations revolving around limiting reagent, percent yield, as well as excess reagent. So this is going to be a question that encompasses pretty much everything that we have done in stoichiometry thus far. We're going to be looking at mole ratios between the limiting reagent and the products. We're going to be determining theoretical yield. We'll be using actual yield to determine percent yield. And we'll also look at the theoretical yield of a product that we may have not focused on in the first place, as well as looking at the amount of excess reagent left over after the reaction has happened. So buckle in. This is going to be a little bit of a longer one because we're going to be doing a whole bunch of calculations. We're going to see how everything fits in together. So let's get started. First things first is that we need a balanced equation, because what it's saying is that we need to find our limiting reagent. Okay, so we have to determine that limiting reagent. Now, even if we were not given that, we are given a value for each of our reactants. And so that has to prompt us to create, or at least find, the limiting reagent. So our reaction says that propane, we have C3H8, and it's in a liquid state, so liquid, burns in the presence of oxygen. So we have O2, which we know is a gas, and it's going to be a complete combustion reaction. So what we know for a complete combustion reaction is that there's going to be carbon dioxide gas and water, either in the liquid or gas form. For grade 11, it's not so important. Grade 12, if you're doing this, it really depends on the states. Usually it's going to be a gas form, and then it would condense down to liquid. But that's neither here nor there. Let's focus on our stoichiometry right now. So we have to balance this. And so what we're going to do is we can see that we have 3 carbons. So I'm going to put a 3 here. I already know that I'm not going to have to double up my fuel because I'm going to have an even number of oxygens. So here I have H8. I'm going to put 4 over here to get my H8. So I have 3 carbons, 6 oxygens, 8 hydrogens, and 4 oxygens. So 6 plus 4 is 10. 10 divided by 2 is 5. And there we go. So I'm going to extract these ratios here, because that's really all we care about after we balance this. So we have 1, 5, 3, 4 as our ratios. Okay, so let's do part A, where we need to find the limiting reagent. So part A, we're actually going to do part A and part B at the same time, because remember, we have to choose a product to compare. So why not just choose B, and we'll be able to kind of do 2 things at once. So we need to list out our reactants. We have C3H8 and we have oxygen, O2. Now we have 17.8 grams of this, and we have 160.4 liters at SATP. So we can use our molar volume to convert liters into moles if we know if it's at SATP or STP. So we need the molar mass for the propane, which is going to be 44.11 grams per mole. And here we know that the molar mass at SATP is 24.8. And so this will allow us to cancel out grams here, cancel out these here, and be left with moles of each. So here we'll have 0.403536613 mole of C3H8. And here we're going to have 6.467741935 mole of O2. Awesome. Now we have to choose a product, and like I said, we're going to do part B at the same time. So we have to find the volume of the gas produced. So the gas produced is the CO2. So I'm going to do a mole ratio between the moles of CO2, and in this case, the mole of C3H8. And here I'm going to do another mole ratio between CO2 and mole of C3H8. Okay, so we get these ratios from our balanced equation. So we have 3 for the CO2s. Again, we put them both on the top because that's what we're trying to compare. We have a 1 over here, and we have a 5 over here. So this will allow us to get rid of the moles of our reactants in both. Oh, that's why we want to use our units there. Okay, mole of O2. And so we're going to be able to get rid of those units and get moles of CO2. So here we're going to have 1.210609839 mole of CO2. And here we're going to produce 3.880645161 mole of CO2. All right, so remember, the limiting reactant or the limiting reagent is the one that produces the least amount of product. And so that's going to be this one right here. So our limiting reagent is going to be our C3H8, and our excess reagent is therefore going to be our O2. So because we found that, remember that this calculation doesn't exist anymore because it's not created from our limiting reagent. So we just found our theoretical yield. This right here is our theoretical yield of CO2. However, part B tells us that we want to find this volume in liters at SATP. So we just need to convert this out. So remember that the molar volume again at SATP is 24.8 liters per mole. And so our moles will cancel out and we will be able to get our answer here, which will be 30.02312401 liters of CO2. And we can use three significant figures because we have 1, 2, 3. So 30.0 liters is going to be how much CO2 is produced. Awesome. All right, so we just did part A and part B. We found that the limiting reagent is our propane, and from that we were able to determine our theoretical yield of CO2, and we converted that into liters at SATP. Okay, so now let's go into part C. It says determine the mass of the liquid produced. So normally we would choose a product to compare, and we did that. We did with CO2, but now we're being asked to find how much of the other product was made. Now this is very simple. So remember that the limiting reagent controls everything. It controls how much of each product is made. So we're going to start there. Remember that our limiting reagent is C3H8, and the amount of limiting reagent we have is 17.8 grams, or better expressed as 0.40 moles of that. So that's what we're going to start off with, and that's what we're going to base our calculation on. So we're going to put 0.403536613 mole of C3H8, and now we want to figure out how much of H2O is going to be produced from this limiting reagent. So we need to do a mole ratio. Remember, anytime we compare, we need a mole ratio. So mole of C3H8 and mole of H2O. So again, we get this from our balanced equation. We have a 4:1 ratio, 4 of H2O and 1 of C3H8. Our units can cancel out, and we get 1.614146452 mole of H2O produced. Again, they want this in grams, so we need a molar mass of H2O, which is 18.02 grams per mole. Again, mole goes on the bottom because we want to cancel that out. And when we do this calculation, we get 29.08691907 grams of H2O produced. Again, we have originally 3 significant figures from our limiting reagent. So that's going to be 29.1 grams of H2O produced. That's it. Okay, so if we ever need to find another product, we always, once we find our limiting reagent, we always use that value for the limiting reagent to base all of our calculations on. All right, now let's look at our part D. It says that if 21.3 liters of gas was produced at SATP, determine the percent yield, again, of that gas. So remember, this is the gas, this is the CO2 that was produced, and this was our theoretical yield of CO2. So to calculate percentage yield, we have PY is equal to actual yield over theoretical yield times 100. And remember that our theoretical yield was 30.0 liters. This is always the one that's calculated. And our actual yield that was just given to us was 21.3 liters. So our liters will cancel out. And what we will get is we will get 0.71 multiplied by 100. And we will get 71.0%. So not too bad. They did a pretty good job. They got 71% of what they or what the max they could have gotten. All right. Now, part E is going to be our excess reagent. So determine the amount of excess reagent left over of the reaction in their appropriate unit. So, for example, the propane was given to us in grams. So if that was the excess reagent, we would need to express that in grams. But in our case, oxygen is our limiting reagent, and it was given to us in liters. So we need to make sure that we convert it at the end into liters. So remember how we do excess reagent. First of all, excess reagent is O2. We first need to figure out how much we have, which we've already done. We then have to figure out how much was used in the reaction. We base that off of our calculation of our limiting reagent. We subtract the two, and then we convert. So how much do we have? So we started off with 160.4 liters, or otherwise expressed as 6.4677 moles. So that's how much we have. We have 6.467741935 mole of O2. Next step is how much did we use? So remember, this is all based on the limiting reagent, and our value of our limiting reagent, which we saw before, was this value over here, okay? So we're gonna base that calculation off of our limiting reagent. So we have 0.403536613 mole of C3H8, and we wanna look at the relationship between the limiting reagent, C3H8, and the excess reagent. And again, we get this from our balanced equation. So there's 5 oxygens for every 1 propane. So 5 oxygens for every 1 propane. Our propanes will cancel out, and we will get 2.017683065 mole of O2 that is actually used up. Okay, so this is how much we are going to use of oxygen in the reaction. So now let's determine how much we have left over. We had 6.467741935 mole of O2 to begin with, but we used 2.017683065 mole of O2 in the reaction. So how much do we have left over? We simply subtract these. We will have 4.450058887 mole of O2 left over. And again, now we want to express it into its appropriate unit. And so that is going to be liters. And again, all of this is done at SATP. So we're just going to use the molar volume at SATP, which again, we want to get rid of moles and liters, and that's going to be 24.8 liters per mole. So our moles will cancel out, and we will get 110.36146 liters. Again, we had everything in 3 significant figures. Now, we can't round that up to 111. So what we're going to do is we're going to have 110 with a decimal, nothing after that decimal, liters, because this will show that that 0 is significant. So this is how much we have left over after the reaction. I hope you found that helpful. It would be helpful if you watched it over and over again to see the different parts. If you have any specific questions about any one of these parts, please watch the videos related to that individual section. For example, if you're looking at more information on limiting reagents or excess reagents or percentage yield, I have a number of videos on those. So please take a look at the playlist and watch those as much as you need to make sure you understand the concepts. Thank you very much for watching. If you haven't done so already, please subscribe, like, and hit that bell notification. I'm putting out a lot of videos to help you out with your chemistry journey. So I really, really appreciate if you can subscribe to this channel. It just helps me get things out to more people. And again, all the best, and we'll see you on the next one.